Good afternoon, everyone.
Good afternoon, ma'am.
Good afternoon, ma'am.
Okay, who will give their presentation today? Yes.
Ma'am, I'll give
What is your enrollment number?
036.
36.
Yes, ma'am.
Okay, start.
Ma'am, can you see my screen?
Yes, I can see your screen.
Okay, ma'am. Good afternoon, everyone. My name is Celeste Nsama. The topic I'm presenting is to observe the variation of potential difference V across a given resistance by changing the current I through it. Draw IV graph and find the value of the given resistance. Our aim here is to observe the variation of potential difference V across a given resistance by changing the current I through it. Draw IV graph and find the value of the given resistance. Materials required: number 1, a battery illuminator or battery; number 2, an insulated copper wire; number 3, an ammeter; number 4, voltmeter; number 5, a rheostat; number 6, a resistor; number 7, a key or one-way tool; number 8, a piece of transistor. Circuit diagram: A ammeter, B voltmeter, R resistor, D battery, K key, RH rheostat. Theory: in an electric circuit, the potential difference V across the metallic wire is directly proportional to the current I flowing through the circuit with a constant temperature. This is known as Ohm's law. Mathematically, V proportional to I, or I proportional to V, or V is equal to IR, or R is equal to V by I, where proportionality constant R is co-resistance offered by the flow of electric current. What are the factors affecting resistance? Following are the factors affecting resistance. Number 1, the nature of the resistor. Number 2, with an increase in length, the resistance also increases, so length also affects the resistance. Number 3, with an increase in the cross-sectional area, the resistance decreases, the cross-sectional area of wire affects the resistance. Arrangement diagram. Procedure. Number 1, arrange the devices as shown in circuit diagram. Number 2, connect the battery with the connecting wires, keeping the key open. Number 3, the positive terminal of the battery should be connected to positive terminal of the ammeter. Number 4, before connecting the voltmeter in the circuit, check for positive and negative terminals. Number 5, check for ammeter and voltmeter reading once the circuit is connected, and also adjust the slider of rheostat after inserting key. Number 6, for current I and voltmeter, we record 3 different readings using slider. Number 7, record the observation in the observation table. Number 8, using the formula R is equal to V by I, calculate the resistance. Number 9, to plot the graph between V and I, take V on the x-axis and I on the y-axis. Number 10, for pure metal, resistance increase with an increase in temperature. Observation table. Number 1, least count of ammeter and voltmeter. Number 1, range of ammeter is 0 to 0.5 ampere. Range of voltmeter is 0 to 0.1 volt. Number 2, least count of ammeter is 0.01 ampere. Least count of voltmeter is 0.01 volt. Number 3, zero error of ammeter is 0. Zero error of voltmeter is 0. Number 4, zero correction of ammeter is 0. Zero correction of voltmeter is 0. For readings of ammeter and voltmeter, current in ampere I, ammeter reading: number 1, 0.02, number 2, 0.03, number 3, 0.04. Potential difference in volts V, voltmeter reading: number 1, 0.04, number 2, 0.06, number 3, 0.08. Resistance in ohms: R is equal to V by I ohm, R1 is equal to 2 ohm, R2 is equal to 2 ohm, R3 is equal to 2 ohm. Graph. ammeter reading on y-axis and voltmeter reading on x-axis. Conclusion. For all the three readings, the R value is same and constant. The ratio of potential difference V and current I is the resistance of resistor. Number 3. With the help of the graph between V and I, Ohm's law is verified as the curve is a straight line. Precautions. Thick copper wire are used as connecting wires and using sandpaper to remove their insulations. To avoid external resistance, the connection should be tight. When there is no current flow, the pointer of ammeter and voltmeter should be at zero. To avoid unnecessary heating in the circuit, the current should be passed for short time. Thank you.
Okay, presentation was good. So when you give your presentation, you don't have to read line by line as your presentation. You can explain in your own words. And where did you get the values, tabulation table values? Where did you get those values?
Ma'am, you gave me on that explain it.
Okay, so tabulation part was not needed actually, and otherwise the presentation was good. Thank you.
Yes, ma'am.
Roll number 36, right?
Yes, ma'am.
Okay. Next. Who is next? Okay, others don't want their internal marks or what? I can't hear your voice. Hello? I think your network is not good.
Ma'am,
Yes?
I will give
Okay, start. What is your enrollment number?
22, ma'am.
22. Okay.
Hello, ma'am.
Yes.
Is it visible?
Yes.
Good afternoon, ma'am and everyone. I present experiment number 1, M, to determine the volume of sphere by using Vernier Caliper apparatus. Vernier Caliper spherical body, such as pendulum box or a glass marble. Description of the measuring device. 1. Vernier caliper is a precision instrument that can be used to measure internal and external distance extremely accurately. Vernier caliper, two, one main scale and a Vernier scale, which slide along the main scale. The main scale and Vernier scale are divided into small divisions through of different magnitude. The main scale of graduated is millimeter. It has two peaks jaw, A and C, projected at right angle to the scale. The sliding Vernier jaw BD. When the two jaws are in constant contact, the zero of the main scale and the zero of the Vernier scale should coincide. The jaw and metric strip are designed to measure the distance by diameter of object. No P is used to slide the Vernier scale to fix the Vernier scale at a desired position. B. Second, the least count of Vernier caliper is the magnitude of the smallest division on the main scale divided by the total number of small divisions on the Vernier scale. The difference in the magnitude of one MSD and one BSD is called the least count of the instrument, as it is the smallest distance that can be measured using the instrument, and BSD equal n minus 1 under bracket MSD. Here's the Vernier caliper figure. CA is fixed jaw and DB is sliding jaw. CD is internal jaw and AB is external jaw. N is depth measuring blade and S is locking screw and M is imperial scale. Formula use least count of Vernier caliper. The magnitude of the smallest division on the main scale by the total number of small divisions of the Vernier scale. Least count of Vernier caliper equal 1 millimeter by 10 division. Vernier constant Vernier caliper equal 0.1 millimeter. And error 0 error. When zero of Vernier scale coincide with the zero of main scale, then error is called zero error, means no error in Vernier caliper. Positive error. When zero of Vernier scale left to the zero of main scale, then error is called positive error. And third, negative error. When zero of Vernier scale right to the zero of main scale, then error is called negative error. Precaution 1. While taking the observation, the eyes must be kept perpendicular to the scale. Second, screw the Vernier tightly without exerting undue pressure to avoid any damage to the thread of the screw. Last one, note down each observation with correct significance, figure, and unit. Ma'am, thank you, ma'am.
Okay, thank you. Enrollment number 22. Your presentation is good, but again, it is for everyone that when you are giving your presentation, don't read those lines line by line. You can try to give the presentation in your own words. Otherwise, your presentation is good. Misa Modi, right? 022.
Ma'am,
Okay. Okay, next. Who is next?
Ma'am,
What is your enrollment number?
ma'am 03.
03. Okay, start.
Am I audible, ma'am?
Yes.
Okay. Good afternoon, everyone. I am G53. So today I'm giving a presentation on physics practical, and the topic is to determine the volume of a sphere by using the Vernier caliper. So the aim of the experiment, and my topic is same, which is to determine the volume of a sphere by using Vernier caliper. For doing this experiment, apparatus required a Vernier caliper, spherical body, which is either be a pendulum or marble. Before doing an experiment, we have to know what is Vernier caliper. Vernier caliper is an instrument which is used to measure the outer dimensions, inner dimensions, and depth of the given object. As you can see in the object, as you will see in the image, that this is the Vernier caliper, which consists of two scales. One is main scale and the Vernier scale. The main scale is graduated in centimeter, while Vernier scale slides along the main scale and is graduated in division, which is millimeter. It has two sets of jaws, upper jaws and lower jaws. Upper jaws are used to measure the internal diameter of the objects, while the lower jaws are used to measure length or the external diameter. There is a depth rod which is used to measure the depth of the object, and screws which is used to fix the vernier scale at the desired position. By using this vernier caliper, we can observe the readings or tabulate in the table. After tabulating the readings, we have to find the least count. What is least count? Least count is the difference between one main scale division and one vernier division. For calculating the least count, there is a formula which is the magnitude of the small division on the main scale divided by the total number of small divisions on the vernier scale. After finding the least count, we have to calculate the volume of a spherical object by using the formula V is equal to 4 by 3 pi r cube. The procedure take the readings is to, we can take the objects and place it between the two lower jaws and observe the readings in the main scale and vernier scale and take out the readings. After finding the readings, we have to calculate and tabulate. First we have to tabulate and then calculate the volume. Thank you.
Okay, this presentation was actually very good, short and simple, and he did not read the lines line by line. He explained in his own words. The presentation is very good.
Thank you.
Okay, next. Who is next?
Ma'am,
Yes.
I.
One by one. Who is next? Ma'am, my network is not good. Okay, you give your presentation in the next class. Okay, who is next?
Ma'am, you can see my screen.
Yes, I can see your screen. What is your number?
050.
50.
Yes, ma'am.
Okay, start.
Good afternoon, one and all. The aim of the experiment is to determine the volume of a sphere by using Vernier caliper. Apparatus required: Vernier caliper, a spherical body such as pendulum web or a glass marble. Theory: a Vernier caliper has two scales, one main scale and a Vernier scale, which slides along the main scale. The main scale and Vernier scale are divided into two divisions, though of different magnitudes. The main scale is graduated centimeter and millimeter. It has to fix jaws A and C projected at right angles to the scale. The sliding Vernier scale has jaws BD and a metallic strip, the zero of the main scale, and a Vernier coincide when the jaws are made to touch each other. The jaws and metallic strips are designed to measure the distance diameter of object. Knob P is used to slide the Vernier scale on the main scale.
Screw S is used to fix the Vernier scale at desired position. Least count of Vernier caliper is magnitude of the smallest division on the main scale divided by number of small division on the Vernier scale. The difference in magnitude of main scale division MST and Vernier scale division VST is called a least count of the instrument, as it is smallest distance that can be measured using the instrument n-1 main scale division. The volume of a sphere V equals to 4 by 3 pi r cube. And this is the figure of Vernier caliper. How we can measure the Vernier caliper? Here are some steps. Step 1. Place sliding jaw against upper step of object. We have to place the sliding jaw against the upper step of the object we are measuring. We have to make sure that head of the caliper is perpendicular to the edge of the upper step. Step 2. Open caliper jaw. And we have to open the caliper using a thumb screw until the fixed upper jaw contains the lower step. Step 3. Turn lock screw. And then we have to turn the lock screw to tighten the jaw so that we can remove our object and take our readings. And then read measure value. A quick guide on how to read a Vernier caliper. A Vernier caliper outputs measurement reading in centimeter and it for size up to 2 decimal place. Example 1.2 centimeter. What we have to note that the measurement reading techniques described in their post until the similar for Vernier caliper with measurement reading inches. Thank you.
Yes, very good. What is your enrollment again? 50, right?
Yes, ma'am.
Okay, very good. But you don't have to go so fast. You can explain the presentation slowly, okay? And
Okay, ma'am.
okay. Next. Okay, who is next? Someone was willing to give their presentation, then some Beauty Burma. Actually, her voice was not clear. Will you give your presentation? My network is not good. Okay, if you have network problem, then try in the next class. Okay, everyone. Then who is next? Okay, don't give network problem as excuse. Okay, her network was actually very bad. I can see. That's why I excused her. Anyone else? No one? So today only 4 students gave their presentation. Roll number 36, roll number 22, roll number 03 and roll number 50. Okay, then give your attendance. But in the next class, I will take 20 presentations. Be ready. Okay, CR, please collect the attendance.
Ma'am,
Yes,
CR is absent.
CR is absent. Can you take the attendance? One student take the collect the attendance. Okay, thank you.